We're going to do one more Atwood's question, but this time we're going to look at something a little different. And these are the questions that get students on the exams. It's not the acceleration, it happens to be this tension stuff here. So we get two masses, M1 and M2. They're connected by a light rope over a light frictionless pulley. So M1 has a mass of 18 kilos, mass 2 has a mass of 30 kilos. Now this time we're being asked to determine the magnitude of the force of tension in the rope. So let's have a look at this. So I'm going to have my Atwood's pulley. I have this first mass here, we'll call that 18 kilos. And then the second one here, I have its mass as 30 kilos. So this works perfectly fine. Now, what we can ask you to do is we can ask you to determine the tension in the rope. There's a few different ways to approach this. Which way you approach it depends on your comfort level. But in order to do these, the first thing you actually need to do is you need to find the acceleration. So the first step, determine A. So we're going to find the acceleration due to gravity. Or the acceleration of this system. So we know that the acceleration is the net force divided by the mass. Once again, we know that the net force is going to be that difference between the two masses times the acceleration due to gravity. And we know the mass is just the total mass of the system. So our acceleration is going to be this m2 minus m1 times g divided by m1 plus m2. So once again, we're going to find that difference in mass. We're going to multiply that by 9.81 meters per second squared, and then we're going to divide this by total mass. And this is going to give us an acceleration for this system. So I'm going to get about 2.4525 meters per second squared. Don't worry about significant digits for now. That's going to come a bit later. Now that we have the acceleration, one might ask, well, you told us that the tension cancels out. When we're looking at the whole system, like when we're considering the pulley and the two masses, yeah, we don't have to factor in tension. But if we want to look at tension, we have to take a closer look at one of the blocks. Which block you use, it doesn't actually matter. So step 2, look at one of the blocks. To find the force of tension, or its magnitude rather. Now for this, I'm going to show you how it works for both blocks to show you that we get the same answer. On an exam, you only need to pick one of them. You don't have to do both. I just want to show you both to convince you that no matter which one you pick, it's going to be the same thing. So I'll start off with the 18 kilogram block, and then we'll work our way to the 30 kilogram block. So in the 18 kilogram block, let's look at it in isolation with a free body diagram. So this 18 kilogram block, it being the lighter one, it's going to accelerate upwards. What that's telling us is that there's that force of tension going up, and then there's that force of gravity that's acting down on that mass. Now, as always, we always want to call our direction of net force the positive direction. So I'm going to call up positive in this context. So what I can say is that the net force acting on block 1, and I'm going to be really careful with my subscripts here, this is going to be Ft plus Fg1. And again, we're only looking at the 18 kilogram block, so everything has to deal with 18 kilograms, or everything when it comes to mass is the 18 kilograms. We're not looking at the whole system. So the force of tension on this is going to be the net force on block 1 minus the force of gravity on block 1, or we know Ma minus Mg. Now the only thing we have to do is we have to be certainly mindful of our signs. So we got the acceleration already. We got it as that 2.4525 meters per second squared. We're told this is a mass of 18 kilos. So acceleration's up. We're going to leave that as a positive number. Now, the only thing I have to watch out for this time is I have to watch out for G. Since the acceleration's going up and the acceleration due to gravity on this block is acting down, this has to go in as a negative 9.81. So negative 9.81 meters per second squared. So we're going to be real careful putting that in. And what we're going to get is we're going to get about 221 newtons. Now, that's for block 1. We said that the tension throughout the rope is constant, so I should be able to look at the 30 kilogram block and I should be able to get the exact same answer. If I don't, we have a bit of a problem here. So let's look at this 30 kilogram block. So the 30 kilogram block is accelerating down because it's heavier, so the force of gravity acting on it is going to be much greater than that force of tension trying to act against it. Now for this block, since the net force is going down, I'm going to call down positive. And that's okay that it's different from the 18 kilogram blocks. We're looking at these two individually isolated from one another. So the net force statement, I can still say the net force is this force of gravity. And the net force on block 2, it's the force of gravity on block 2 plus that force of tension. We're still solving for the force of tension, so the force of tension is going to be this net force on block 2 minus this force of gravity on block 2. Or again, M2A minus M2G. It looks deceptively similar to that of the 18 kilogram block, with just M1 switch with M2. Kind of like with the elevator problems, the finesse here is the directions that we have to be a little bit careful with. So in this question here, A is going to be down because this block is accelerating down. G is also going to be down. So those are both going to be input as positive numbers. So the force of tension is going to be my second block here, my mass, 30 kilograms. We found that acceleration earlier. And then we're going to subtract off the mass. And then we're just going to leave G alone as positive 9.81 meters per second squared. Since it's going down already, we don't have to do anything special with that. So we're just going to leave that be. And what we're going to get here is we're going to get about negative 221 newtons. Now you might say to yourself, well, they look similar, but one's got a positive, one's got a negative. That's okay. This is just telling us the direction. The negative is telling us that because we called down positive, the negative tells us Ft goes up. That's fine. In terms of magnitude, it's 221. So we get the same magnitude on the force of tension regardless of which block we pick. So we're just going to say that the magnitude of the force of tension is 221 newtons. Which block you want to pick to examine doesn't actually matter. You can pick either one, but just keep in mind you're looking at that particular block in isolation. You don't care about the other block when you're looking at the force of tension.